One of the most useful ways to take advantage of electrochemistry is what's known as a galvanic cell. This is essentially what we now call nowadays a battery, though galvanic cells are not just limited to batteries. But this is where we have a redox reaction happening, and we separate out the reduction and oxidation and cause the electrons to flow through an external circuit. And so that's what happens, in the batteries that you use in your cell phones, laptops, in any portable electronic device that we have utilizes a galvanic cell of some kind. We can also use galvanic cells to do analytical measurements, as we'll see. And so the idea is that we can either set this up as a spontaneous reaction, and so I have here a specific galvanic cell. This is the lead acid battery, and this is the battery that's commonly used inside of regular cars, not electric cars. Those are lithium-ion batteries, but a lead acid battery is used to start your car, right? So it provides that electrical spark to ignite the fuel to start the internal combustion engine. And so we can either set it up where we have a spontaneous reaction occurring and electrons flowing. So this represents the battery discharging. Or we can set it up if we apply current, we can charge the battery up. And so this here is we're charging the battery, kind of running it opposite of how it would run when it's charging. And so the total reaction happening here in this particular battery, let me see if I have enough space here. All right, so we have lead solid plus lead oxide solid plus sulfuric acid, that's aqueous, and the products are lead sulfate, that's a solid, and water. All right, and so this is our reaction here. And so that's why this is known as the lead acid battery. We have two different forms of lead. We have neutral lead metal as well as lead oxide. And these are in different oxidation states, right? So lead metal, this is in an oxidation state of 0. We write the oxidation number. Whereas lead oxide is in an oxidation state of +4. And so in the course of this reaction, lead is both oxidized and reduced. Right, so the lead oxide goes from this +4 state to over here in the lead sulfate. Now here it's a +2 state. And so our lead oxide is reduced, whereas our lead metal is oxidized and goes from 0 to +2. So we can write this out as two half reactions that happen on different sides of this galvanic cell. So we have, we can think of this as being divided up into two parts. So one where the lead is oxidized, and so that's our lead metal. So this is the oxidation. Lead plus sulfate going to lead sulfate. All right. Plus 2 electrons. Like charges don't match up there. And then the reduction half reaction is that we have our lead oxide plus sulfate plus 4 hydrogen ions plus 2 electrons, because we're doing reduction here, goes to our lead sulfate plus water. Okay, and so each of these reactions is happening in a different part of the cell, and the electrons are being passed in between. So the two sides of our cell are known as the cathode and the anode. The cathode is where reduction happens, and the anode is where the oxidation happens. And you can see in this figure that we have here, at the anode we have that oxidation reaction happening, right? We have the lead is turning into lead sulfate. Lead is turning lead sulfate. Whereas on the reduction side, we have the lead oxide turning into lead and then forming this solid, turning into lead ions. All right, so The words cathode and anode come from a way down and a way up in, I believe, Latin. So anode oxidation, the electrons go up. Cathode, where reduction happens, the electrons come down. In terms of thinking this as positive or negative, the electrons go towards the more positive side. So the cathode is our positive electrode, and the anode is our negative electrode. So the electrons are coming from the anode and going to the cathode. Now, I always find it difficult to remember which one is which, cathode and anode, which one's reduction, which one's oxidation. One simple mnemonic device that works for me, you can, maybe there's something else you've learned, but both cathode and reduction start with a consonant, and both anode and oxidation start with a vowel. So that's something that works for me to remember which one goes with which. But this is one example of how we can have these two reactions happening in separate places, and we make the electrons have to go through a wire to do the electrical work that we want to do. If we want to measure the potential of this, we can use a device called a potentiometer, which would go where this light bulb is here. And when we're actually doing potentiometry, that's what we use instead of having an actual, a circuit with a lot of current going through it. We have very little current. We have something that has a very high resistance to electricity going through it, but we can still measure that potential difference. So that's an introduction to galvanic cells. We'll talk a little bit more about constructing them in the next video, as well as some notation we use to sort of shorthand write down what's going on in a galvanic cell.